All right, so I want to show you this terrain system, basically allowing you to build an island shape and do almost whatever you want on that island shape for how it might look and come across. And it's purely it's just generated at random. You can do all sorts of things to manipulate this. And if you haven't seen any of the earlier videos where I get into this, the actual construction of the island is already done, where we generate the Perlin noise. We use Perlin noise over terrain to edit it in real time and create these rolling hills, and then we upgrade it into various shapes of slopes, and then we combined it finally into one set. So the previous video, the most recent video, where we have 3 sets of Perlin noise, 3 sets of slopes all combined together, that's where we left off. So this one, we're adding that smooth, rounded edge onto the side. So let's dive in and take a look. I mean, all of these functionalities still work, and we can create all sorts of different shapes and designs on this to effectively generate whatever type of terrain style we want. Additionally, reminder on this one is that if you haven't messed with it, it's these parts over here that let you really tweak and manipulate how this stuff shows up and looks. So I can put in entirely different shapes and designs for it, make it look all smooth, make it look all jagged, alien, whatever I want it to look like. All right, so now let's take a look at the code. How do I get this smoothed off, rounded edge? Well, the basic idea is that how far we are from the center, we're putting a range in there. I actually have a photo of it. Do I have that photo of it? Maybe I do, maybe I don't. Just a whiteboard. You know what? The whiteboard doesn't really show. This is me working out the problem on the whiteboard because for some reason, I've done this 100 times, but I couldn't remember it this time. So I had to write everything out. Anyway, it'd probably be easier to follow the code here. So let's go into the code. And before in the code, one of the things that what I'm doing this time is I have an edge reduction map. And this way, here's what happens is when we were producing our code before, we were producing our terrain, we were redrawing the terrain mesh, and we used it to generate this mesh of all these values right here, combining together to produce whatever effect we're finally going to come up with for our Perlin terrain. Now I'm multiplying it by the same XY position in this float array called edge reduction map. So edge reduction map, all it is another set of floats value between 0 and 1. And so we're saying that anything in that, we're basically just prefiguring out where all those go. So every time that we process the heights and manipulate any other part of this, we don't need to reprocess what the heights are supposed to be or how it slopes and cuts off. So our island shape, that bowl shape, that dome shape that we get, that is effectively defined right here. It's already there. So we're just taking it and multiplying it. If it's close enough to the center, it's going to be multiplied by 1. We get the exact same number it came up with originally. If it gets outer towards the edges, then it's going to be closer to 0 or somewhere in between. Okay, so we had to generate this map. So let's take a look at where we're generating the map. First off, when we're doing this, so we have our edge reduction map, and the thing that is defining where that is this, where is it? Percent distance from edge. That is that cutoff. So starting from the square edge, so we have the square for the terrain, starting from that edge to the center point, that is the distance. We're taking a percentage of it. So if we're at 0.5, then that's going to be 50% of the way from the center point to the edge of the terrain. Once we have that edge of the terrain, if we make a manipulation on it, we need to know if we changed it. So in addition to just having this variable, we're also storing the previous value of it. That way, in onValidate, we detect, is it different? If it's different from the current one, if it's not different from the current one, we don't process this. We skip rebuilding that edge reduction map. Okay, so That is interesting. There is a point that I'm missing in this. When I change the slope values for this, it doesn't rebuild the map automatically, but I want it to. So this should also be checking to see if the slope happened to have changed. I wonder if there's a way to detect that. I'm kind of curious. I'm going to do, what was it? Edge border. That is this item right up here. Edge border dot value. Can I compare? Equals. I'll have to take a look at this. I have to see if there's a way to determine that. All right, so I'm going to skip that. That's something I can fix later. For right now, we'll just go through this. So as long as the value changed, it's going to rebuild that reduction map. And let's dive into it. Okay, so in it, the first thing we do is set the previous value to the current value. Normally, that's something you do at the end of the function, but the only reason we're doing it is just to evaluate whether or not we needed to do it. Technically, I could just take this line, Control X, and just move it up here. That works for me. Okay, so first line of this function is that we reset the edge reduction map. We take the height res, that is the resolution of the terrain that we're using, the height map resolution. Okay, so the next thing is we get the halfway point. Why do I get the halfway point? Is because I'm ending up using that I'm using that a lot later on. I could multiply it. Now, actually, I guess I'm not. There were other versions of the code, like for instance, this one, which when you look at it, let's see, I had half in here. I don't even see half in this one. There was another one that I was using half in, whatever. But this was an example of a square edge where I was creating this, because I've seen other samples online where they showed creating it with a square edge, but then you end up with this edge right here that stands out on this side, plus the whole thing is kind of square looking, and that stands out to me. I wanted more of circular, but with inlets and everything to help identify that. Okay, so going back over to here, we get the halfway point, which I guess we don't need that much, but I'm using it in the next 4 lines, so sure, yeah, keep it. Okay, that's the height res divided by 2, so that's basically from the edge halfway across to the center point. Next, we get the center point, which is just half and half. Now, that is slightly off because remember the actual, on this system, it's 513 by 513. So it's an odd number. So technically, we would be ending off on a decimal place when we divide it by 2. But with the inch, it actually comes out to 512 by 512. Because there's a 0 counting. So we actually get 256 out of this, and we don't have to worry about that decimal place. And that's our center point. It is our legitimate center point of this. Okay. Next, we get the high border. High border, what do I mean from that? So we've got that value where we say percentage from edge. And that is the point where we start dropping down. So that point on the terrain, whatever we set that to, we want it to be, let's say it's 50% out. That is going to be 50% of half. So we're going to say once we get out, so right now half is 256. Once we get out to 128, we're going to start sloping down until we get all the way to the edge. That's what we want here. So we need to define how far out is that high border. Originally, it was just a percentage. I want to use a percentage because on the terrains, we could change the resolution and still should have the same general shape of the island, just better, just more or higher fidelity. Okay. So it's basically taking that and multiplying it by half. So 256 becomes 128 if that was 50%. All right, next we get a range. The range is basically where are we actually changing the values from. So if the point is at 128 or the point is at 256, well then the range is 128. It's 256 minus 128, which comes out to 128 again. All right, now we go through every single point inside of that mesh. So every point we're going to figure out what height it needs to be. So to begin with, we're going to get the distance. This is the overall distance, sort of. I'm doing one modification on this. So our distance, we're getting the distance from that center point to where we are now. But then I'm subtracting the high border from it. So if we're at 129, that we're just inside of the range that we want to start sloping down. If we're at 129, we are going to subtract the high border from it. So now we are at 1, but we are inside of the range. And we basically just say, hey, if the distance we just calculated is less than 0, then we haven't even met that range yet, because it's whatever value we had minus 128. So if we were at 110, then we're going to be at negative 18. So we haven't reached the edge of the map yet. So that gives me that. I just tell it it's automatically 1, it's full height, and then we continue. Otherwise, if the distance is actually greater than the range, because so far we've subtracted down that border range, so now our distance is literally that cutoff spot. When do we actually cut it off? So if the distance is greater than range at this point, then we know it's 0, because we've reached the edge of the slopes. All right, we set it to 0, and we continue. And then finally, we pass it to here, where we say, okay, it's distance divided by range. But now let's say that that range, if it were one of the reasons I like to put this stuff in math, or onto a whiteboard, is so I can follow it. I like to put values on it. So if the original distance was 10, and then the second distance to the edge was 15, that means our range is 5. So we have a range of 5 points. And now let's say that we originally came in at 11, so that's 11 minus that first range that shows up over here. And so then we have 1 out of 5. That's 20%. So over here we say our percentage that we are is the point, however much that was, which has already been subtracted from, we subtract D1, that distance from it. And what did I call it in our code? High border. I've already subtracted the high border from it, or D1. So in this case, it comes out as 11 minus 10, so we get 1. And so it's now 1 divided by 5, or 0.2, to get that decimal place, that percentage. But it's the wrong direction, because we're really close to the high border. We should be at 0.8. So instead we do a 1 minus that percentage, and we end up getting 0.8 instead of 0.2. So inside of our code, we end up getting this distance divided by range, so our 0.2 becomes a 0.8 as we do the 1 minus. Now I'm passing that into our edge border evaluate, which is our slope, and that gives us our definition of how it looks on the edges. So this shape right here, which I have to do in 2 steps, I'll put one up. Actually, I'll just put a really jagged one in like that, and then let's adjust that. So you can see we have these edges. Here's the edges all the way in there, but then with the slope in there, I'm getting these tiers of an island. Tiers of an island. It sounds like a poem. All right. And of course, this can't see any of these changes right away, so I have to do that. But we start getting these differing border sections. So effectively what I need to do next on this is figure out how, with one bug in this, I've got to figure out how to compare 2 sets of this if there's already functionality to it. I don't know if the equals actually works for this. A lot of objects type don't actually take care of that. I'm hoping this does, otherwise I have to write my own. Okay, so that's it. We've effectively got this system in here that checks all of these whatever changes we have in this out, and we get different types of slopes, different types of shapes that come in from this. Let's see, where did I get that? This, I'm going to add a key and just drop it down even further like that, and change that there. So we end up with whatever shape and heights that we're going to be dealing with to create our terrain, to create our island. We can spend a lot of experimentation with this to kind of see which things we actually like the most. That one has almost no effect. Oh, its height is next to nothing. There. Anyway, so you can define this stuff entirely procedurally. I recommend at this stage, if you're doing it, that this is a designer tool. So the designer can come in and tweak the numbers and find values that create initial terrain shapes. Because now the rest of the terrain tools still work. I can still come in here and adjust heights. Let's see, raise or lower terrain, which that was a terrible example. Let's see, stroke, we're going to go with brush strength. We're going to add some jitter. Brush size we're going to increase. There. Of course, if I change any values in this, it all just goes right back to where it was. All right. So I hope you find this valuable. Let me know what you think. If you have any particular directions that you want this to come out to, the link to the previous videos is down below in the description, and also a copy of the source code as I was using it for this video is in there as well. All right, thanks.